Ptolemy, a towering figure in ancient science, lived in Alexandria, Egypt, Tuktok. His full name was Claudius Ptolemaeus. He was a Greek mathematician, astronomer, geographer, and astrologer. His most influential work is undoubtedly the Almagest. This monumental treatise compiled centuries of Greek astronomical knowledge. It presented a comprehensive geocentric model of the universe. The Almagest served as the definitive astronomical textbook for over 1400 years. Its impact on subsequent scientific thought was profound and far-reaching. Ptolemy's Almagest was originally titled Mathematique Syntaxis, meaning mathematical treatise. Later, Arab scholars referred to it as Almagesti, meaning the greatest. This title eventually evolved into Almagest in the West. The work consists of 13 books, each dedicated to a specific aspect of astronomy. It begins with a philosophical justification for studying the heavens. Ptolemy then systematically describes his geocentric cosmology. He placed the Earth at the center of the universe. All other celestial bodies, including the sun, moon, and planets, revolved around it. This geocentric model was not entirely new. It built upon the ideas of earlier Greek thinkers like Aristotle and Hipparchus. However, Ptolemy refined and formalized these concepts with unprecedented mathematical rigor. Introduced complex mechanisms to explain observed planetary motions. These included epicycles, deferents, and equants. Epicycles were small circles on which planets moved. These epicycles themselves moved along larger circles called deferents. The equant point was an imaginary point from which the angular speed of the deferent appeared constant. These intricate geometric constructions allowed Ptolemy to predict planetary positions with remarkable accuracy for his time. His model accounted for phenomena like retrograde motion. Retrograde motion is the apparent backward movement of planets in the night sky. Without these devices, a simple circular orbit around the Earth could not explain such observations. Ptolemy's genius lay in his ability to synthesize existing data and create a coherent, predictive system. He meticulously documented his observations and calculations. The Almagest also contained a detailed star catalog. This catalog listed 1022 stars, grouped into 48 constellations. For each star, Ptolemy provided its celestial coordinates and magnitude. This star catalog was largely based on the earlier work of Hipparchus. However, Ptolemy updated and expanded it. The catalog became an indispensable reference for astronomers and navigators for centuries. It allowed for precise identification of stars and constellations. Ptolemy's methodology was empirical, relying on observation and mathematical modeling. He understood the importance of accurate measurements. He described the various astronomical instruments in the Almagest. These included the armillary sphere and the trichetrum. These instruments were used to measure celestial angles and positions. His work demonstrated a sophisticated understanding of trigonometry. He developed tables of chords, which were equivalent to modern Sine tables. The Almagest was translated into Arabic in the 9th century. This translation was crucial for its preservation and dissemination. Islamic scholars embraced Ptolemy's work. Most followers embraced Ptolemy's work. They meticulously studied, critiqued, and built upon it. Many Arabic astronomical terms, still used today, originated from this period. Observatories in the Islamic world flourished, making new observations. Scholars like al-Battani and al-Tusi made significant contributions. They refined Ptolemy's parameters and even proposed alternative models. Eventually, the Almagest made its way back to Europe. It was translated from Arabic into Latin in the 12th century. This reintroduction sparked a revival of astronomical studies in medieval Europe. Universities across the continent adopted it as the standard text. For centuries, Ptolemy's geocentric model remained unchallenged. It aligned well with philosophical and theological views of the time. The Earth's central position resonated with human importance in the cosmos. However, over time, discrepancies between Ptolemy's predictions and actual observations began to accumulate. The model became increasingly complex. Astronomers added more epicycles to account for new data. This complexity eventually led to questions about its fundamental accuracy. The need for a simpler, more elegant explanation grew. This intellectual ferment set the stage for a revolutionary shift. Nicolaus Copernicus, in the 16th century, proposed a heliocentric model. His model placed the sun, not the Earth, at the center of the universe. Copernicus's De Revolutionibus Orbium Coelestium directly challenged the Almagest. This marked the beginning of the Copernican revolution. Galileo Galilei's telescopic observations provided further evidence for heliocentrism. Johannes Kepler's laws of planetary motion described elliptical orbits. Isaac Newton's law of universal gravitation provided a physical explanation. Despite its eventual overthrow, the Almagest's historical significance cannot be overstated. It was a masterpiece of ancient scientific thought. It provided a coherent framework for understanding the cosmos. It demonstrated the power of mathematical reasoning applied to natural phenomena. Ptolemy's work laid the groundwork for future astronomical inquiry. It inspired generations of scholars to observe, measure, and theorize. The Almagest is a testament to human intellectual endeavor. It represents the pinnacle of ancient Greek astronomy. Its detailed star catalog was used for navigation and astrology. Its mathematical methods influenced later scientific developments. Even its errors were productive, stimulating new research. The Almagest shaped humanity's view of the universe for over a millennium. It remains a crucial document in the history of science. Ptolemy's legacy extends beyond astronomy. His work in geography, optics, and astrology was also influential. He was a polymath whose contributions spanned many fields. The Almagest stands as a monument to his intellectual prowess. It is a foundational text in the history of science. Understanding the Almagest is essential for comprehending the evolution of astronomy. It shows how scientific models are built, refined, and eventually superseded. The meticulous detail within its pages is astounding. Ptolemy's dedication to empirical observation was exemplary. He synthesized vast amounts of data from his predecessors. He then presented it in a structured and logical manner. The Almagest was more than just a collection of facts. It was a complete theoretical system. It offered a predictive framework for celestial events. Its influence permeated various cultures. Scholars in Baghdad, Cordoba, and Cairo studied it intently. They translated it, commented on it, and improved upon it. The Islamic Golden Age saw significant advancements in astronomy. Many of these advancements were built upon Ptolemaic foundations. Without the Almagest, this progress might have taken a different path. The erection of the Almagest to medieval Europe was a pivotal moment. It reignited interest in classical learning. It provided a rigorous scientific text for study. European scholars grappled with its complexities. They sought to reconcile its teachings with their own observations. This intellectual struggle ultimately led to new discoveries. Almagest's geocentric model, though incorrect, was a rational attempt to explain the universe. It was based on the best available evidence at the time. The apparent motion of the sun, moon, and stars around the Earth is a direct observation. It took centuries of further observation and theoretical development to challenge this intuitive view. The shift from geocentrism to heliocentrism was a profound paradigm shift. Ptolemy's work highlights the iterative nature of scientific progress. Models are proposed, tested, and refined. When they can no longer explain new observations, they are replaced. The Almagest is a prime example of a highly successful scientific model. It dominated thought for an extraordinary period. Its eventual replacement does not diminish its historical importance. It taught astronomers how to think systematically. It provided a common language and set of tools. The Almagest was a testament to the power of mathematics in describing the natural world. It inspired a tradition of precise astronomical measurement. Its star catalog was a practical tool for many applications. The book's structure itself was a model of scientific exposition. Each book built upon the previous one. Arguments were presented logically and supported by evidence. Ptolemy's writing style was clear and authoritative. This made the Almagest accessible to scholars. It facilitated its widespread adoption and study. The Almagest's legacy is not just about its content. It is also about its role in the history of ideas. It shaped how people conceived of the cosmos. It influenced art, literature, and philosophy. The Ptolemaic universe was the universe for generations. Its imagery permeated cultural understanding. Even today, studying the Almagest offers valuable insights. It reveals the intellectual landscape of antiquity. It shows the challenges faced by early scientists. It underscores the human desire to understand our place in the universe. Ptolemy's work remains a cornerstone of astronomical history. It is a foundational text for anyone interested in the origins of science. The meticulous detail in his star catalog is still impressive. He carefully recorded the positions of celestial bodies. These records were vital for tracking changes over time. His observations, though limited by ancient technology, were remarkably precise. Almagest is a window into the scientific mind of the ancient world. It showcases the dedication required for such monumental undertakings. The influence of the Almagest on navigation was immense. Sailors rely on star charts derived from its data. It helped them find their way across vast oceans. The practical applications of Ptolemy's theoretical work were significant. It was not merely an academic exercise. The Almagest also played a role in the development of astrology. Astrologers used its planetary models for their predictions. The connection between astronomy and astrology was strong in ancient times. Ptolemy himself wrote a treatise on astrology, De Tetrabiblos. This further cemented his influence across various disciplines. The sheer volume of information contained within the Almagest is staggering. It covers spherical trigonometry, planetary theory, and eclipses. It is a comprehensive summary of ancient astronomy. No other work from antiquity matched its scope and detail. It truly was the greatest treatise. Its enduring presence in scientific discourse is remarkable. Even when challenged, it provided the framework for debate. Copernicus, Kepler, and Galileo all engaged with Ptolemy's ideas. They had to understand the Almagest to propose their alternatives. It was the standard against which new theories were measured. The Almagest represents a pinnacle of ancient Greek intellectual achievement. It synthesized centuries of observation and mathematical thought. It provided a coherent, if ultimately incorrect, model of the universe. Its influence on the development of science is undeniable. It remains a testament to the power of human reason. The work's longevity speaks volumes about its quality. For over a millennium, it was the unchallenged authority. This longevity is a rare feat in scientific history. It highlights the thoroughness and mathematical sophistication of Ptolemy's approach. The Almagest shaped the course of astronomy for generations. It is a cornerstone of our scientific heritage.